What do you call the force on a balloon? Sphere pressure. And lots of balloons give in to sphere pressure. It's pretty pervasive out there. So today we're talking about spheres, and we'll be talking about volume and surface area. So first of all, let's take a look at your math chart formulas. I'm very sad to say I can't show you the derivation for these two formulas. I've tried to look around to see a more basic geometric one, but most of them are actually based on using a calculus, and you are not that far yet. So let's go ahead and use the formulas and trust that they are true. I have seen their derivations, and I'm going to show you how to use them. So first of all, let's take a look at the steps for solving the problems. First thing you need to know when working with spheres are what is its radius. Now sometimes you could be looking for the radius, but if you have it, write the value down with proper units. Do not confuse the radius with the diameter. Diameter's all the way across. Radius is from the edge to the center, or halfway across if you want to think of it that way. Write down the appropriate formula for either the volume or the surface area from your math chart. And I have both those formulas showing right here, and they are also in your notes. So even if you don't have a math chart with you, your notes can be quite helpful. There are some important terms in sphere problems. R, which we've been using already, is the radius. V is volume, and S is surface area. A hemisphere is half of a sphere. You probably heard it like Western Hemisphere tends to refer to like North America, South America, this half of the globe. The Eastern Hemisphere would refer to the other side, normally like Asia. So the great circle is the circle that divides a sphere into two hemispheres. So on a planetary basis, you could say that would be the equator, which I've been to, by the way. So the great circle would be this part right here. The diameter is the distance all the way across the circle, and the radius is just half of the diameter. Now, once you get the proper formula down and you've written down the values you know, the information, you want to substitute the values into the formula and simplify. Now use the pi symbol instead of any approximations. I know a lot of you want to use 3.14. This will lead to minor errors in rounding. So try to use pi until the very end. So you're going to have the equation, and then what you want to do is isolate the unknown. So until you have the isolated unknown, do not put in 3.14. Use the calculator button later. So using the pi symbol on your calculator, approximate the volume or the surface area to the specified place value. Once you have gotten the value, make sure you use proper units. Units for volume is cubic units or units cubed. And volume is three-dimensional, so the exponent is 3. See the 3 here and the 3 there. Units for surface area is square units, or units with a little 2 on it. Area is two-dimensional, so the exponent is 2. And it might not hurt to think of squarea. That kind of helps you remember that area is square units. Now for our first example. We're going to find the surface area and volume of a sphere with a diameter of 16 yards. So we're going to find both the exact values and approximate values to the nearest hundred. So you'll see how I hold onto the pi until the very end. First thing you always want to do is write down the information from the problem. We know the diameter is 16 yards, so I can figure out that the radius is 8 yards. I'm looking for both S and V. So I'll start with S. Start by writing the formula from the math chart and substituting. So actually I'm going to draw the picture here. You can see there's the radius is 8. There's the formula for surface area. So this is straight from the math chart, except for the yards, the units. And I substitute in the 8 for R. 8 squared is 64. I can multiply the 4 and the 64, and that gives me 256 pi. So this is the exact answer when I still have the pi there. And then when I use my calculator, I approximate, and I get 804.25, or 804 and 25/100ths of a yard squared. To find the volume, I also need to write down the volume formula, which is 4/3 pi r cubed. 4/3 times pi times 8 cubed. 4/3 times pi times 512. Notice I'm writing it down and just doing a step at a time. This is really a good practice for you as well. Now I've got it down here. I multiply the 4 times 512, and this is my exact answer for the volume. And then using my calculator, I get an approximate answer of 2,144 and 66 hundredths of yards cubed, cubic yards, if you want to say it that way. In example 2, the size of a cultured pearl is typically, and a pearl is like on a necklace. They're the little white things for those of you who may not be used to cultured pearls. So the cultured pearl, you get them from the oysters and you can make a necklace, and they're little spheres. So typically, the size of a cultured pearl is indicated by its diameter. So the bigger the diameter, the bigger the pearls. How many times as great to the 10th is the volume of the 9mm pearl as the volume of a 6mm pearl? So for both of these, I have two spheres that I'm looking at the volume. So I write down the diameters for both, which gives me the radii for both. The radius for the large one is 4.5 millimeters, and the radius for the small one is 3 millimeters. I'll find the volume first of the large one. Notice how I wrote down from the math chart the formula, and I put a little 1 because I'm dealing with two different volumes. Then I'm going to substitute in this 4.5 millimeters in and cube it. Using my calculator, this is what I get. So far, I actually still have an exact answer. Then I get this part here, multiplying the 4 times the 91 and 125 thousandths. And then finally I get 381, and I rounded. So I just rounded to the 10th here. Now I want to find the volume of the smaller pearl. Same process, I write down the formula, substitute in that radius and cube it. 3 cubed is 27. And by the way, these actually simplify. I can actually put a 9 here. And 4 times 9 is 36, so that's how I got 36 pi. Then once I use my calculator, I get 113.1 millimeters cubed. By the way, this is rounded, so I did approximate there. And I want to know how many times greater is this volume compared to that volume. So what I'm going to do is put the larger volume over the smaller volume. And then using my calculator, I get 3.4 times greater. Example 3. Find the surface area to the nearest square centimeter of a hemisphere with a volume of 144 pi centimeters cubed. So they gave us an exact area. Notice how it has pi right here. So what I'm going to do is write down what I know. I know the volume is 144 pi. I'm looking for the surface area, which is S, and I know because I'm looking for the surface area, I'm going to need the radius. So first of all, let's write down the formula for the thing I do know, which is volume. But you're probably saying, hey, I already know volume. Why do I need the formula? Well, the formula will actually help me find the radius. So I'm going to substitute in here, and that's pretty much it. So let's see, 144 pi, see how I took this value here and substituted it in, equals 4/3 pi r cubed. Now I could divide both sides by pi, and that will simplify the pi. The pi goes away. So I get 144 equals 4/3 r cubed. One way I can get rid of the 4/3 is by multiplying the reciprocal, because the 3's and the 3's cancel there, and the 4 and the 4. That all simplifies to 1. So on this side, I just have r cubed equals this value right here. I went ahead and used my calculator, and I found 108 is equal to r cubed. Now, if I told you a number cubed is 108 and I want the number, you need to go backwards. So instead of cubing, you do the cube root. Using the calculator, and this is a math function, we go the cube root of 108 equals r. So let me go ahead and just pick up my calculator right now so I can tell you what the function is, and I'll go over it in class. If you go math and then you go 4, that gives you a cube root. Okay, so my calculator gave me 4 76/100ths of a centimeter. I went ahead and tried to get this out. I know it says the nearest square centimeter on surface area, but I want to kind of get it out a couple of places just to keep the accuracy. Now I'm going to write down the formula for surface area, which is 4 pi r squared. I'm going to take this value right here and substitute it in for r right there. So S equals 4 times pi times 4.76 squared. Using the calculator, I get 284.7 centimeters squared. Since I'm rounding to the nearest whole centimeter, when I say nearest square centimeter, that means the nearest whole. I have my answer is 285 square centimeters. In our last example, I'm giving the surface area and now I want to find the volume. So it says find the volume to the nearest hundredth of a sphere with surface area of 625 pi meters cubed. So the information I know is that the surface area is 625 pi meters cubed squared, and I'm looking for volume. And if I'm looking for volume, I'm probably going to need the radius. So surface area, I'm going to go ahead and write down the formula for this. Again, you might say, hey, I already know surface area. Why do I want to write down the formula for that? Well, this is going to help you find the radius. So what's going to happen is I'm going to take this 625 and put it right in there for S. 625 pi equals 4 pi r squared. Now these two pi's, I could divide both sides by pi, and they will cancel. So I'm going to get 625 equals 4r squared. Then I can divide both sides by 4, because I have 4 times r squared equals 625. Dividing by 4 tells me that r squared is 156 1/4. Now I can just find r by taking the square root, and I actually find out it's 12.5. Now to find the volume. So it's like I'm halfway there. I found the radius. I'm still trying to find the volume. So write down the volume formula from your math chart, which is 4 over 3 pi r cubed. So this 12.5 is going to come and substitute in right there. 4/3 times pi times 12.5 cubed. Now notice when I'm doing a straight calculation and all my knowns are on the right, I'm not as picky about writing the v down as I work down here. But when I'm trying to solve for an unknown like a radius, like on this left side, I try to make sure I have something on both sides of that equal sign. Hopefully you can see the difference there. Now using my calculator, I cube 12.5 and I multiply it by 4, and I get a crazy number, 7,812.5 times pi. Pi doesn't go away, divided by 3. Using my calculator, I finally get 8,181 and 23 hundredths of a cubic meter.